Hello and welcome to the episode 6 of OpenTTD Code Deep Dive. In the last episode, I showed the blitter, graphic driver, and subsystem initialization. If you find presented content useful, don't forget to press like button and subscribe. We left off with the network startup, so let's continue there. I already started the debugger, so we have network startup function, and it will initialize the core of the network, which actually is only applicable for Windows. Okay, I'm on Linux, so nothing here. Okay, so network initialize. And then we'll initialize the network pools. So we have the pool type, which is normal pool connection, network client pools, network admin pools, new GFR over data. Okay, so network client. Close admins. Reset the, so it will, word admin pool has to be cleared as well. Okay. Okay, and then it will be set. Okay, while it's set, additionally, then there's also some clean stuff. So we get the pools, and okay, there's some pool vector, which is actually, okay, so for different types of pools, there's probably just, yeah, okay. Yeah, so company pool, depot pool. So I believe that we'll have just the pre-allocated objects that we can just get from the pool. And then for here, we just have the, we just set the network type, pool type. So I believe this will just test the bit, and if it matches, it will just clean the pool. And oh, okay, interesting. Is it here? We may check if it's gonna trigger. Yeah, okay. And what's the cleaning? What's the pool about, and what's the cleaning about? Here we see it's like the alias, or actually macro for some templated type. It's actually the pool type. Let's see. What do you have here? Okay, so some kind of item, bitmap storage. So this is probably in the typed. And then we just, yeah, this is the data we just saw, and then we just clear that, and we just string that, just make sure that it's empty. The same for bitmaps. And tcache, the cache is probably here. The template parameter is probably false for this one at least. Yeah, this is network client info pool. Okay. All right. Oh, we don't need to be here. So let's get back from the clean. So we have the pools. Then there's some sync frame. The frame to perform the sync check. Set up to 0. And some other properties. We'll probably not do much of the network in soon, so but just to give you an idea what's happening here. So we have UDP initialization. If not close, it was actually never initialized, I guess. So okay, and then we create this socket handler. Zip response. Okay, nice. It's basically the socket for the global UDP client. Yeah. So we have a socket and we register the handler. And then we have the network address list. It's probably the vector. Yep, okay, I learned the convention already. What's the network address about? Yeah, so host name. This is the sock address structure, the resolve address. Nice. And then we get the band address. Okay, there's no network band list actually. It's empty. Okay. So we just put the empty one and the 0. Okay. Yeah, so we use this address list, which is actually one element vector, and then we just create this socket handler, and this should be initialized with some server as it was passed as the parameter. So that's how I would guess it's done. And just that it's the smart pointer. Yeah. And server is here. So it's just actually the address list here. The server is address list. Okay, so since this was successful, we just print that multiplier is available and find broadcasts at IPs. Okay, this is still empty. So we look up the addresses and okay, is it transparent? Yeah, sort of. Okay, so we see that it's like a local network address. And we just check if it has the broadcast flag enabled. If it has the address, let's see here. Maybe it's easier to check here. Okay, it doesn't seem it has. It has something. Am I looking at the correct thing? IFA. This one? Okay. Okay, and we also check the family. So let's see if anything like this triggers. Okay, so here we are. Okay, maybe it's some kind of union actually. Yeah, it's a union. That's why I don't see it here. It's not displayed. Or it's actually in displayed, it's just like this. Yeah, so here's the family of the addresses, and you can see that we look up for family2, which actually is a match here. Then the network address, so initialize the structure, or actually the class, with the socket address, the address length, so we check if it's resolved, and we just copy the address into this this address structure, socket address storage. Yeah, we which is just like this. Okay. And then we just add to the broadcast. So to this address list we just so we first iterate through the list. If it does not match the address, then we just push it into that. So so I believe now this list should have another element. It's the same. Seems like the same thing. It just that maybe, oops, the address is different. Okay, it's not visible not nicely here. All right, so we have two addresses now. And this will just free, yeah, it's just a system call to free the structures we allocated here. And since we have two addresses, we can just get on top of them and just for each, we just add the default port, which is 3979. So this is the UDP port that you'll be using. You should unblock it if you wanna play with UDP protocol over the network. And we should have also display the local address. Yeah, so this is my local network address. No, sorry, it's a broadcast address in this case, but in my local network. Okay, and there was like our interface that was found, and then we have also HTTP initialization, which does nothing for at least for this implementation. Okay, so it seems that we are done with the network, so we can handle the bootstrap now. Handle all procedures for bootstrapping OpenTTD without a base graphics set. Okay. All right. And we're done. Really. Yeah, I think we just exit, right? Why does it happen? Okay, because getUseSet was actually initialized already. It's maybe because we already been here. That's interesting. For the base graphics set. All right. So maybe there is some special condition that, you know, it's there's no base graphics set for some reason, and there's just some branch to actually support that. But we are not here, so we'll just skip into the video driver, and here we pick up an instance again, the driver. So we have already seen that. So we have the active driver for the video, and we saw how it's interesting. It's not picking the default driver that we already selected, but actually the logic is same here. So the same one should be picked up. And claim mouse pointer. So it says, okay, show cursor. All right. That's okay. And then we have the sounds. So next section is about sounds. And we have this class which is just about the base media. And then we have a find set. And this is again just scanning in the base media. So the one that we know. We just scan for files. I'm just thinking if there's anything specific about it that's a base sound. We're just kind of scanning through the sets. And then we know this was not initialized. And there's some initialized. So this is the same pattern we have for other things like driver. And then we set by name. And we have no sound. Okay, it's probably because this, by default, there's no sound really. So maybe not much to see here. What does it do? So we have some available sets here. Just a static value. And okay, none is none. I'm just wondering if there is some null pattern implemented here. It is. So what it is? Okay, it's just some mock kind of thing, I guess. Sound pack without any sound. Okay, so there are translations. Yeah, so empty sound set. Okay, not perfect probably. I should get back to it probably once I get the sounds. For now, we'll just live with that. So probably it will be just the same thing about the sets for the music. It's interesting that it's called again, although it seems like really the same function all over again. Maybe there are some globals which make the difference. And then, yeah, we probably the same here. And then there will be no music, I believe. No. Okay, too fast. Let's get back. Oh, maybe name was empty. Yeah, the name was empty, though there was really no music. So again, set by name. This one is empty. Okay, so moving on, just empty set. So, and then the sound driver is actually empty. So, so the selection of the driver, we already saw that with the graphics driver. The only difference is the type is different. So I wouldn't expect much difference here, except for that here we check for DT video and the hardware acceleration. Which makes something a bit, maybe it's a bit different then. But well, we may have a look. Okay. Right. Okay. So what kind of driver we have here? So we have SDL sound driver actually. The driver is there. It's just that there's no music in the base package. At least I haven't prepared it properly. So what does the music driver do? So we have the instance of sound driver, the SDL sound driver this time, and it just have some start stop stuff mostly. So we'll create an instance, and what does it do on start? Oh, come on. Okay, so we check if the SDL was initialized. It was. If so, this okay. So this is about the whole SDL initialization, and here is only about the audio system. So we call the audio initialization here, and it's successful. And then I don't think we have any params here. So frequency is just 44 kilohertz. Or sorry, 44 hertz. Yeah. No, 44 kilohertz. Yeah. And 44,000 hertz. Okay, and this is the format. Is it like signed 16? Yeah, I would guess so. And then 2 channels, 1000 samples. Fill sound buffer is something that will be used as a callback. And then we just open device with this specification. Well, for frequency change, and boom, we have the device. And then mx initialize. What's that? So we have the mutex. And then we say the play rate. Okay, this is our frequency. Max size. Okay, interesting that it's here in max. I'm not sure what context does it use, but okay. So just some basic things to initialize here. Then pause audio device, so it's not started immediately. That's how I understand. And yeah, and we should be done. Driver is activated. This was for sound, and there's also for music. And what's the music driver about? So I would believe, is it the same? So we had a sound driver previously, and now this is the music driver. Okay. Oh, because it's a MIDI driver. That's fair. So how does the MIDI driver works here? So for some reason we pick up the video driver. Okay, which is probably not compatible with some Allegro driver. I don't know this driver, but it's not this one. We don't have any command here. So probably some external thing can be launched. Command tokens, no, nothing here. Oh, we had some command. Oh, this is the default command, right? So timidity, which is some default MIDI driver, external MIDI driver. So okay, something pops up here. It's only the one. And okay, so this has for the following things here. So like song, command tokens, Yeah, and if it's like an external, yeah, MIDI is probably external MIDI, so we bring the external player or something like this, or so, and this inherits from music driver, which is just about playing songs and setting volumes, such things. So, okay, we just initialized it to empty things and -1 some defaults, and it's there. Okay, so the next thing would be generate world, which sounds like a big enough chunk for the next episode. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.